Hi girls, I'm on STEM conference today, so here's what you do. We are doing integration by substitution today. So this is a brand new concept, but I have actually mentioned some part of this during an example of such thing like this. So in other words, what we're trying to integrate right now is not just a simple power function about x. It's kind of a function of a function. So when we mention function of function, it should relate it to when we do derivative, it's the chain rule. However, this is a simple case. That's why I said the component of this function, it's just 3 because that is a derivative of whatever inside. But we can't actually do that without putting a third outside. And then we can actually integrate this as a whole thing through the normal integration process, which gives you 3x plus 1 to the power of 6 over 18 plus 6. Now, this is a very simple example. However, what we are trying to be dealing with today is something that we're trying to integrate is no longer just x again. It's not just a linear function either. It's something that is keeping more complicated, which means such as like this. Integrating x to the power of 4, 2x power 5 minus 1 to the whole power of 3. Now, this function looks very complicated, and obviously we can't just integrating x to the power of 4 and then integrating this bit for whatever imaginary method and then multiply them together, because integration process cannot be applied to product individually. So before that, this is what we're trying to do for the lesson. So let's start the title. Sorry, let's some notes. Now we will use integration by substitution when the integral involves a function of a function. In this particular case, the function is 2x to the power 5 minus 1. And we place this function inside another power function of 3. That's what makes a function of a function. And to be quite honest, this x to the power 4 is actually some part of your component. I'll talk about that in a minute. So in this case, we will use integration by substitution to deal with such function like this. And please be aware, integration by substitution it's not limited to power function only. And we are going to be using integration by substitution a lot in any other function later on. And there's another name, which I mentioned before in the previous example when we did this kind of linear function of a function, is reverse chain rule. And that is basically another name for integration by substitution without substitution. Oops. So reverse chain rule is basically doing the same process without actually doing the substitution itself. But you definitely need to know integration by substitution. So I will be doing most of these questions by integration of substitution. And then I'll also do it again with reverse chain rule. And then you'll see the connection in between them. So let's start with the first question. This is the one we try to deal with. Now, we evaluate or find this integral using the substitution. Now, before I tell you what the substitution is, it's basically the target function. Basically, what you're trying to raise the power. Remember, we have only learned power function for now. It doesn't mean that you can't put it in any other type. You can, but we will do that later. For now, we are putting this power function inside a power of 3 function. So that becomes a function of a function. So in other words, we are going to let whatever inside as our substitute. In other words, letting u equals to 2x to the power 5 minus 1. Now, so our whole point is to replace everything in here by u, including dx. So replace all x's by u. So that's what we're trying to do. All right, so that's why the x to the power 4 has to be there. You'll see that very soon. So now, when we do integration by substitution, we always separate it into two sides. One side is a normal integral. The other side is the substitution process. To start, we let u equals to 2x5d minus 1. So what's the first thing we need to do? Because we have dx right here. Therefore, we also will differentiate u with respect to x. That is one of the most important reasons why I always ask you to write the derivative in this way instead of y dash. So if you use u dash in this case, it doesn't actually help you to do the substitution. So you should actually write du over dx equals to 10x to the power 4. Okay, and why do we need to do that? Because later on now, you can combine your x to the power 4 with this dx becomes some kind of du. And remember, we are replacing every single x inside this question by u, including the dx. And the question provided x to the power 4 dx. We're trying to make this exactly the same. So if you multiply both sides by dx from this equation, dx. But we don't have 10x to the power 4, do we? We have x to the power 4. So therefore, we just need to divide both sides by 10 to get exactly what's provided in the question in order to help us to do the substitution. So therefore, now once you've done this step, x to the power 4 combined with the dx, that is your du over 10. Remember, over 10 is just a constant. We can take it out anytime. And 2x5 minus 1, that is your u. Therefore, that becomes u to the power of 3 multiplied by du over 10. And this du over 10 is from these two combined together by this substitution. All right? And then now you can just take out the constant 1 on 10 out, getting u3 du. Remember, you can only integrate with the right variable. If it's a u inside your function, the last one has to be du. It can't be dx. If it's still a dx, that means you haven't done the proper substitution yet. Therefore, this becomes 1 on 10 multiplied by u4 over 4 plus c. Don't forget this is an indefinite integral. Any line that you have finished evaluating this integration sign, you have to plus a c. And that will give us u4 over 40 plus c. But unfortunately, that's not the end of the question, because we have the original question is to try to integrate it with respect to x. So all you need to do is to replace your u again by the substitution you did. 40 plus c. So this is the full process of doing this question with integration by substitution. So here we go. Now I'll do reverse chain rule. In fact, I'll talk about reverse chain rule later in a more systematic way. I'll do a few more integration by substitution with you first. So let's have a look with the next question. Let's find x squared root x cubed plus 1 dx. And now, if you have thought about that, you should actually have some kind of idea what we should actually make for substitute instead of just telling you what that is. In this case, the substitution should be uq plus 1. In other words, you let u equals to x cubed plus 1. The reason is the derivative of x cubed is x squared, 3x squared somehow, but you can manipulate the constant, and that's the x squared at the top, at the front doing. So now if you started with u equals to x cubed plus 1, then du over dx should be 3x squared. And du equals to 3x squared dx. And is that good enough? Not yet. The reason is we don't have 3x squared. We only got x squared. Therefore, just rearrange it a little bit. Get exactly the same thing that's provided in the question to make your substitution. Therefore, if you replace now, this is square root of u. And that gives us du over 3. Okay, and then if you take 1/3 out, change it into index form, it'll help you a little better. And that will becomes 1/3 multiplied by u to the power of 3 over 2 divided by 3 over 2 plus c, again, indefinite integral. So now everything is clear. That's 2 over 9, u to the power of 3 on 2 plus c. And again, don't forget that's not the end of the question because you're not looking for u. You are supposed to be looking for x. Therefore, that is x cubed plus 1, 3 over 2 plus c. And there are lots of different ways of expressing this. You can put this into an index form. You can put it in the cube or the square root of x cubed plus 1 q plus c, or you can do 2 over 9, get 1 out. It's up to you. All valid. They're all valid answer. Depends on what question is looking for. And so therefore that is technically saying that is the technique of using integration by substitution. Now let's do a few more easy ones first to get you started. For example, if we have x multiplied by 3x squared minus 9 to the power of 5 dx. Okay, so now let's do integration by substitution again. Obviously, in this case, we let u equals to 3x squared minus 9 du over dx. That is 6x. And du equals to 6x dx. And du on 6 equals to x dx. Remember, that's what we are provided. Therefore, if you integrate it, that becomes u to the power 5 multiplied by du over 6. Take it out. And that is u 6 over 6 plus c. And that becomes u to the power of 6 on 36 plus c. And that is 3x squared minus 9 to the power of 6 on 36 plus c. Okay, now we'll come back to more integration by substitution in the next video.